Alright, in this video I want to show you how to graph an equation of a line, and in this case the equation is 2x minus 5y equals 10. Now perhaps you might have learned in a previous course or some other way that we could make up a table, an x and a y table, to graph this thing. Right? We could make up some x and y table and plug in some numbers for x, or plug in some numbers for y, and plot some points. But I'm not going to do that this time. I'm going to show you a different way to graph this. So I'm going to slide this aside for a second. Let me show you a different way to graph an equation. First, let's start off with what we are given. And I'm going to take this equation and turn it into this form called y equals mx plus b. Alright, maybe you've seen that form before. This is a popular form of an equation of a line. In fact, it's called the slope-intercept form because the this coefficient of the x, is the slope. And this b over here, this number that's going to be sitting all by itself, is called the y-intercept. So what we need to do to this equation, 2x minus 5y equals 10, is to make it look like this one over here. We want y all by itself and everybody else on the other side of the equation. So the first thing we're going to do is we're going to move this 2x over to the other side of the equation. To do that, we're simply going to subtract 2x from both sides. Have you ever heard the phrase change sides, change signs? So in this case, if I'm going to bring that positive 2x to the other side of the equal sign, it becomes a negative 2x. Okay, well, I have to do one more thing to get my y completely by itself. I have to get rid of that negative 5. And since negative 5 is being multiplied by y, we're going to divide every term by a negative 5. Right, divide every term by a negative 5. That now leaves us with a coefficient of 1 in front of the y. And since I have a negative 2 divided by a negative 5, hey, a negative divided by a negative, that's just a positive, so I'll just write it as a positive 2/5. And obviously 10 divided by negative 5 is a negative 2. Okay, so now this equation looks like what I was after, this slope-intercept form. And I've got all the players that I need. I hope you see, if you see it in this form, that this coefficient of x, this thing in front of the x, is my slope. This guy here is my slope, 2/5, and this negative 2 sitting here all by itself on at the very end of my equation is what we call a y-intercept. All right. So to graph an equation like this, we don't have to plot any coordinates or anything like that. What we're going to do instead, let's see if I can keep this in there. Actually, maybe what I'll do is I'll just rewrite the equation this way. All right, so what we're going to do instead then is we're going to start off by plotting the y-intercept. That's the first thing we're going to do. And that's always the first thing we're going to do when you use this form here. So on the y-axis, I need to find negative 2. So I've got my graph paper here. I'm just going to go down negative 1, negative 2, and I'm going to put a dot right there. Maybe I should do this in red so you can see it in contrasting colors here. Alright, so I'm going to put a dot here at negative 2, and the reason I put that there again is I did this first. I did the y-intercept first. Okay. Then from there we're going to do the slope. Now slope is always rise over run, so from this point, not from the origin, but from that y-intercept, I'm going to go up 2. Right, I'm going to go up 2, that's 1, 2, up, and then to the right 5. 1, 2, 3, 4, 5, and then put a second dot. Okay, so that is called, right, this little shortcut here is using the slope-intercept, right, form of an equation of a line to graph what our line looks like. And now I'll just have to connect these dots. That's my last step here. Connect these dots up, and our line looks something like that. And I like to draw nice long lines, no wimpy small lines. Okay, so there it is. Without even doing a table at all, I'm not even using that method at all. All I did was I isolated the y, and now that I've got my y completely by itself, I have an equation where I can pick off the y-intercept. That's the first thing I'm going to find, and then from there I'm going to do the slope. Well, let's say, for example, let's make up one more of these. Let's say, for example, I had an equation that looked like this. This is just a completely separate question now. What if I had something like negative 3/4 x plus, how about, 7, something like that, right? What would that look like? Well, let me show you how that looks, and it's slightly different because it's got a negative slope this time. Well, again, the first thing we're going to do is we're going to tackle that y-intercept. We got to go find that first. So I'm just going to go up 1, 2, 3, 4, 5, 6, 7, and put a dot. So the y-intercept is the first thing we do. And again, it's a y-intercept, not an x-intercept. Notice I'm not finding anything on the x-axis first. That is the y-intercept. Okay, so from there, what I like to do when I tackle these things is, since this is negative, right, this is a negative slope, I'm going to go down 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4, and then put a dot. Okay, so I went down 3. From here I went down 3 to the right 4, put a dot, and if I connect them up, I've got the line that corresponds, right? I like to put arrows on the end because these technically, right, are lines, and lines go on and on forever. So this equation here is this line here. Right? That top equation here was this line here. So negative slopes, right, when you have a negative slope, they go down as you're looking at it from left to right, and positive slopes like this one up here go up as you're looking at it from left to right. Now, one more thing I want to show you. What if we play the game slightly backwards? Okay, what if the game is played this way? What if I give you the graph and I ask you what's the equation? We could do that too. Right? My math lab does that sometimes to you, or the homework might do this to you. Okay, so what if I give you the picture and I ask you to find the equation of the line in slope-intercept form? Well, slope-intercept form, again, always starts off like this, right, where y is all by itself. We have this thing in front of the x called the slope, and we have this thing over here all by itself, this number all by itself, a constant, which is where it crosses the y-axis. So let's start with that. Where does this line, this red line that I have here, where does it cross the y-axis? Well, I hope you see it crosses the y-axis right here. Right? That thing is right, this thing right here is called the y-intercept. And let's see, in my case it's 1, 2, 3, 4, 5. That's a positive 5 sitting right there. So here's what I know so far. I know that this thing, this number that's sitting here all by itself, is a positive 5. I know that for sure. Right? If it crossed down here somewhere, it would be a negative number. It would be minus something. But since it's crossing right here, it's a positive 5. So I'm just going to put a plus 5. So the last thing then is I need to know, what is the slope? Now remember what I said a moment ago. When you see a line going down from left to right, okay, I'm reading the line this way. I'm looking at it, panning across the page this way. When you see the line going down like this, down, I know it's got to be a negative slope. I know it's a negative something. Okay, so automatically I can put the minus sign in there right now. Put a minus sign in there. I know it's going to be negative something. I was also given this other point over here. So what I'm going to do is I'm going to go from here, I'm going to go down 1, 2, 3, 4, 5, 6, 7, right? 6, 7, and then over to the right 1. So I'm going to go down 7 to the right 1. Hey, that's a 7 on top and a 1 on the bottom. Because remember that slope is always rise over run. It's always the up and down stuff over the left and right stuff. Okay, so from here to here you can go down 7 and then to the right 1, and that gets you to this other point that we are given. So I'm going to finish this off. I guess I really don't need the 1 on the bottom. I'm going to finish this off and say, okay, the equation of this line is y equals negative 7x plus 5. There's the equation of that line. Right? And if there was any other denominator other than a 1, I would include it. You know, maybe if we went to the right 2 or 3 or 4, something like that, I would include that instead. But since it's over 1, I don't need to include it. Hope that helps.